So, first of all, thanks for being here. There are lots of interesting talks, and it's fascinating how many people go to the not interesting talks. But thanks anyway. My name is FX, or Felix from the German Phenolite group. I'm as many hackers, I'm a security consultant in my professional life, running Sabre Labs, which is the professional services side of Hyver's cyber security company. And today I'm here talking about analyzing complex systems, and with the example of how we worked on the Blackberry. If I sound a bit funny, that's the sound system. No, seriously, I'm just a bit sick. So let's start. When you're looking at a complex system, like you plan, okay, we went ahead and said, okay, so several people asked us to look at Blackberry as a whole because like everyone uses it. They're called crackberries by now because they make addictive. And so everyone wants use that, but like all the security people say, look, like my CEO is running around with this thing and I don't know shit about it. So could you guys in your spare time, because we don't have any money to spend on that, look at this stuff and tell us if it's secure or not. So if you're approaching something like this, you first need to get a bigger picture. Whoever does the sound, it sounds really funny. Like I have echo here, so I'm not entirely sure if I should take different drugs, but okay. The big picture. Why do you need a big picture? What you see is what you get is usually not a very good approach when you go to a complex system. In the case of a Blackberry, like the intuitive step is you take a device and you just look at it from all sides and say, okay, what can I do with this? Can I attack it or not? But the device is just one part of a very large system. And you shouldn't immediately like take this device and go and start trying to hack it. If nothing else, the best reason why you should not do that is because the defender, in this case the vendor of the device, probably put most of the security into what you have in your hand, what you see first, like the devices. Like the CEO is going to take this device and say, is this secure? And RIM is going to say, yes, it is secure. So it's usually, in absolutely all cases I've seen, not a good idea to go right to the first thing you see. Also, the bigger picture is needed to find what's really a promising attack vector. You have this, again, this Blackberry device and you're not sure. I mean, it does email, you can surf the web, you can get calls, whatever. You don't really know what will be a useful attack vector. Like in which position do I have to be to attack someone? And of course, you have to concentrate on something. I mean, taking something apart is not easily done. I mean, if it's a Cisco, it takes you a week or two. But if it's a thing like Blackberries, it's going to take quite a while. And unless you have a 3-letter acronym as your company or your agency, which supposedly has unlimited resources, then you have to like deal with your resources and find what you should really look at. Speaking of resources, you have to find out what you actually need to do the research you want to do. Like, what hardware do we need? Do we need special hardware? In the case of a Blackberry, it would be quite useful to actually have a device. What software do you need? Like, do I need special debugging software? Do I need whatever? What infrastructure do you need? Again, in a Blackberry case, the thing is not going to be anything else than a fancy, clumsy mobile phone unless you have an account somewhere where you can actually do, like, pull your email or get your email pushed. So you actually need accounts. Someone is breaking into it. Hi. That's the other talk. And of course, what tools do you need? So getting what you need actually might take time. In my case, I wanted a BlackBerry Enterprise server, and that's something you don't go to the shop around the corner and say, can I have a BlackBerry Enterprise server CD, please? So you have to call people, figure out who could have this piece of software, who could give it to you, stuff like that. And of course, like, trying to get stuff might have consequences. Like, how much money do you want to invest? Can you afford investing money? Can you afford crossing legal lines? For example, like getting the BlackBerry Enterprise Server software wasn't actually legal for me. Was it a big legal crossing? No, probably not. So that's the last point. Do you care? Like, for everything you look at, do you care? Like, if you're doing research in your company and it's costing money, do you care or not? And very important is, can you afford the target you're researching to know that it is potentially under attack? That's a very interesting thing, because if you ever did professional pen testing, you've probably come across a situation where you attack a system and the administrators know that a pen test is going on and secured while you're attacking it. Like, you create an account, you want to use the account, and the account is gone in the same minute. Or they close ports where you found vulnerable software or stuff like that. Same for bigger targets. For complex systems, it's the same deal. If you're playing with the system too noisy, they might notice that there's an issue. Like, if you're trying to find vulnerabilities in a webmail system and you send email that crashes the system, you're surely gonna make them aware of the fact that they have a software problem. So before anything else, make sure you identify all components. As I said, don't stop with the handheld device. Go and find what's there. And don't miss the non-obvious components. So this is RIM's version of the big picture. We have like the handhelds. Oh, let's go downstairs here. We have the handheld side with like third-party devices running BlackBerry stuff. We have the native BlackBerry devices. Then we have several different mobile networks, which is fairly important. Then there's like lots of arrows here and one arrow through the internet. So obviously there's something missing here. Then we have the big bad internet. Firewall, more or less. We don't know how this puke through the firewall looks like. And then we have wireless policies and all the different crap on the server side, interfacing to Exchange and other services. And then in a small print, it says like web applications and internal blah, blah, and whatnot. So there's quite a lot on this official big picture that you want to look at. The first thing you should do is get an abstract big picture. Like, figure out what are the core components we're interested in, which is, in this case, we see, again, this is sport. We have the evil BlackBerry, GSM network, in my case. Then you've seen those arrows on the slide before, so you have provider-side servers, which is at least for the end user accounts, because if you buy a BlackBerry from T-Mobile and use it privately, it's gonna come with a pre-configured account. But that has to run on some servers. So you have in a GSM network provider side, you have RIM servers, then you have somehow a connection to the RIM secret network. You have those RIM hubs that people connect to. On the corporate network side, you have an enterprise server, and you have management software to that, which is also a small piece of thing that people usually overlook. There has to be a management interface to all the infrastructure. And that has to have more powers to it than the average end user, especially if you're looking at this connection versus this connection. And this has a connection to the RIM side as well. So taking a step back and making it more abstract gives you a way better idea what potential targets are. So when you break it down, you have the handheld devices, the mobile network, the RIM network, you have some internet-based communication, a BlackBerry Enterprise server, a BlackBerry Enterprise server connector that talks to your mail system, and you have management tools. Now with this list, you can go ahead and reclassify them in terms of what are they. Like for the handheld system, it's an embedded system, obviously. It's proprietary hardware, fairly important because you don't get like pinouts and PCB layouts on the internet. It has obviously a real-time operating system, otherwise it wouldn't do GSM and you wouldn't have clear calls. And it obviously runs Java because the software is slow. So on the mobile network side, you have a 2.5 or 3G GSM network with everything that comes with GSM functionality, which interfaces with the handheld. You have the RIM network, which is unknown. We don't know anything about it, but we can be pretty sure that they're not running on IPX, so it's probably IP-based. We have internet-based communication between the enterprise servers and RIM, and that's pretty sure IP-based, otherwise it would be a pain in the ass to route. And it's probably a proprietary protocol. That's easy to check. You open the sniffer, Etherreel, you look at 5 packets, Etherreel says IP, TCP, data. Okay, so it's proprietary. You have a Blackberry enterprise server, which is Windows-based server software, and it's closed source. And the management tools is the same thing, Windows-based, and it's client-server software. Now, with the reclassification, you can also go ahead and see how's the accessibility? Like, how easy is it to get to one of those components? Handheld device, doable, just costs money. Mobile network, pretty hard because people tend to defend their GSM networks, but also pretty illegal. RIM network, I would say fairly doable compared to GSM network, but still fairly illegal. Internet-based communication, well, doable. The only thing you need is a working installation. Very important. You need a working enterprise server installation talking to RIM. Blackberry enterprise server, well, pretty easy. See our lady IDA. Same for the management tools. And then, very interesting is look at what would be the impact of a successful attack. Like sit back, drink a beer, smoke a cigarette or whatever you prefer, and just like imagine you were already done for each and every component, and then think what would be the impact of a successful attack here. For the handheld devices, it would be, of course, information disclosure. You would read someone else's email. And potentially you would have remote control over some poor ass at the airport. But that's just one single user. With a mobile network, you could redirect all the communication and stuff, but well, if you own an entire GSM network, there's better things to do than play around with the Blackberries accessing it. The RIM network, well, that would be pretty fun because you have full control over the infrastructure. You actually are RIM. So you can finally prove all the claims about the security and stuff. Internet-based communication, if you like have successful attacks on that, you can impersonate one of the 2 communication points unless there's very strong crypto in place. And also, you can do brute force attacks on both sides. Just even if you don't know if there's passwords involved or anything, you know if you speak the protocol, if you have reverse engineered the protocol, you can be one of both sides. So it enables you to play around with malformed protocol attacks. It enables you to do brute force in case there is a password. It gives you all the functionality you need to script it. For the enterprise server, if you have a successful attack, you get code execution on a host OS. And that means you own a server that's centrally placed in an infrastructure. To give you an idea what the enterprise server actually does is like someone comes in with a box to your company and places the box there and you ask, what is it? Like the chief security officer asks, what is this box? And well, it's an enterprise server for Blackberries. The CEO wants it. And so what does it do? It connects out to the internet to RIM. Fine. And what else does it do? Well, it connects to our mail system and needs administrative access on it. So that should pretty much clarify how much impact a code execution attack on such a system would have. For the management tools, you could modify policies, you could modify the configuration if you own them. You could send messages to everyone, and you may be able to install software on all the Blackberries that are managed by this enterprise server. So like all the board gets porn screensavers or whatnot. This means you can draw up a graph or a diagram and like put in all the connections that you have here and see how easy is the access to it on one side and what's the impact. And if you place those things, then it becomes pretty clear what your research should concentrate on. Because, like, as I said, the enterprise server is easily accessible. It is Windows-based, so we have all the debug infrastructure. We don't have to solder stuff to a device or something. It is centrally placed. It will probably have access to everyone's email, not just one account. And, well, code execution is fine. You have, like, Metasploit and everything. You don't even need custom shell codes. And, well, you can own a pretty interesting machine inside a corporate network. And this should show why going right after the handheld device will be a very, very stupid idea. Now, once you get the big picture, you need to get the details right. Because the details are what matters to make the big picture correct. Otherwise, you end up having a big picture which depicts not the system you're attacking, but something similar. So details decide, for example, how hard will it be to find a usable attack for that. So you have to like take the enterprise server binaries, throw them into IDA, and see if IDA is going to puke on them. Because there are situations where IDA is not very helpful. Just name like Delphi code where IDA just really sucks. What tools do you need for your work? Like, as I said, we need a working installation. How feasible is the attack in general? Like, if I have an attack on a specific piece of software that handles, in this case, email messages, can I reach this piece of software, or is it hidden somewhere in the enterprise network? In case of email, it's fairly obvious. You can send email to everyone you want. But still, you have to consider that for the general case. And then how illegal is the attack? Meaning, do I have to own an entire provider network to execute the attack? Or, and that's not for the research side, but for the actual execution of the attack, or do I just send an email? So, for the handheld devices, the details were fairly interesting because there is a simulation environment available, which helps a lot. There is a developer SDK available. The current version is for Java. The older version is for C, which of course was a lot more interesting looking at. But it had a limitation in accessibility, meaning that only residents of the United States and Canada could get to it. That's what the website said. This is a case where accessibility wasn't really an issue. I mean, even I know people in the US, and even I can call them and say, look, could you like send a fax over to RIM and get this SDK for me? Thank you. You have desktop software, and you have third-party code. That's like third-party products that you can put on a BlackBerry, which is, again, quite useful because you can take the third-party products, make more or less legal copies of it, and like see what's in there. Like what API do they use? What can they do with the API? Because that tells you how much power you have behind the API, even if you don't have documentation for it. For the protocols, it's really just firing up the sniffer and finding out how many communication channels do we actually have. Like, does it connect to 500 different systems in the internet, or is it just one? How does it figure out what system to connect to? Who initiates the connection? Is it stateless or stateful? Is it connection-oriented? How much encapsulation do we see or suspect? When you look at the protocols and you have a protocol that has lots of encapsulation levels, then the code parsing that is probably in a tree-like structure. So you have a parser for the outer encapsulation, then it figures out what's in there, then you have a parser for the next level of encapsulation, and so on and so on and so on. Which means that probably a lot of people are working on this code and not really talking to each other because you can modularize it really easy in development. On the other side, if you have a flat, big protocol thing, then the parser is probably written by one crazy Russian and is one huge piece of code. Without doing lots of reverse engineering, by looking at the protocol, you can at least guess how much work it's going to be or how likely it is that you find useful attacks. And how variable is the protocol design? Example, SAP uses like strict fixed length protocols that have like fixed length fields. There's pretty much nothing in this damn protocol that you can overflow because it's all fixed to 8 characters. So on a server software, how is the software designed? Are we running userland, service, kernel? What security context do we have? What privileges does the software need? Especially if you have multiple modules of the software, different processes, you have to look, okay, I have like 5 processes. One is running as nobody, one is running as system, 2 are kernel drivers or whatever, and then figure out what those things are doing. And the best case combination, meaning high level of privilege and much exposure to the outside, is the one you're going to look at. I mean, the enterprise software comes on a CD, I think it's 300 something megabytes or something. But if you go for a software that's big enough to not fit into IDA completely, you have to decide where to go. Otherwise, you're researching till you're 80 and the software is outdated for 20 years or something. And of course, as I said, what programming language was used is very important. But also, what coding style do we see? Do we see like university style slapped together C++, or do we see Russian E-technician code where variables probably never had more than 2 characters? What coding style is there? Because that tells you again what types of bugs to expect. Things to look for. History is very important and very powerful. If you just take half a day surfing the company's website and press releases, where does this stuff come from? Did they bought the technology? Did they invent it? How old is it? What generations were there in between? Check the press releases. And then documentation. What are like setup requirements? What do you have to have? Like probably you have to be administrator to install it, but in which context does the machine run? What troubleshooting procedures are recommended if something doesn't work? What troubleshooting procedures are actually used? Forums are, Web 2.0 is really good for that because like people are posting all this stuff on the internet saying, yeah, troubleshooting procedure doesn't work, I just reboot the machine. Or other people say, I just reinstall the software. That gives you a very good idea of how the level of administrators is working with this stuff. So if nothing else, it tells you how likely it is that they get to you when you own them. And whatever you read, take it as a hint, not as a fact. So, like the third step then is what you can't really do a presentation on, is do the actual work, which can be quite painful, and everyone has different ways of dealing with that. Well, and then somehow you get to results, hopefully. So first things for the handheld was strip it. Yeah, you're not buying cats in a bag. So before you marry a female, you probably do the same thing. So we wanted to figure out what's actually in there because it turned out to be a really, really useful move. And it actually wasn't really our idea. Frank Rieger from CCC came up with that. He said, well, before you start reverse engineering the binaries, you should better figure out what CPU it is. And it turns out that was really good because the simulation environment still worked on a 386 type of architecture, which they used in really early handheld devices that more looked like a pager. But then later on, they moved over to ARM, embedded in an, I think it's analog devices over here, on an ARM CPU. So we knew it was an ARM CPU. When you turn the thing around, that's the front view. That's not very interesting. So as I said, turns out to be ARM. It runs different real-time operating systems, or real-time operating system kernels, I should say. For example, the 7290 runs on a KDAC AMX4 kernel, which turned out to be the surprise even to some people from RIM. Other devices run on entirely RIM proprietary code, but it's different for each and every model. So we have the same situation as with Cisco here. Again, that tells us that writing an exploit for the lower level kernel areas would be not a very smart idea, because you would have an exploit for a specific type of device and not for the whole range. The binary images do the actual neo-hardware communication, like GSM implementation and stuff. Not even RIM implements that in Java. And then you have loadable modules, which is quite an interesting concept. What they do is they use DLL files, regular PE-COF format like we have on Windows, just compiled for the ARM architecture, which is totally doable. And they link into the main operating system binary, which is called RIM-OS-EXE. So there is a modular architecture in there, so there might be the possibility to add modules or change module loading or stuff like that. And then you have the handheld JVM, the virtual machine, which is implemented as one of those loadable modules. So you have a jvm.dll that's actually flashed onto the device. RIM actually re-implemented the entire JVM. So whatever is there on fixed Java bugs in JVMs from Sun or from HP, okay, sorry, HP doesn't fix bugs, IBM or someone else, it might actually work at the RIM JVM, or they might have different bugs. So it's really interesting to know that there is a specific JVM. Unfortunately, the classes set is not very big, especially the reflection API is missing, so you can't really play interesting tricks with them. Device control runs over RIM classes. So you have a set of classes, rim.blah, blah, 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 that do all the device control. They display messages on the screen. You can do whatever you want functionality-wise on a Blackberry as a developer. Unfortunately, if you don't use RIM classes, if you limit yourself to the Java classes, you can't do anything. I mean, what you can do is like add two numbers or something, but you can't even do input or output. So you have to use the RIM classes, which kind of sucks because you have to use signed code to actually import RIM classes or link to RIM classes. Oh my God. Okay, so how the signing works is you make a hash of your Java binary, you send it to RIM, the hash, you pay $100 by credit card to get a account, and then you get it signed by RIM. Now the suspicion here is that you go ahead and they collect all the hashes, so in case someone writes a worm for Blackberries, they would actually know who wrote the worm, which is an interesting idea, considered that there are no stolen credit cards on this planet, and there is no way to have an anonymous credit card account. The firmware itself is signed as well, so you can't just like modify the firmware. I tried that. The loader checks the signature on the firmware, which is easily circumvented by like the shortest IDA manual ever. This is how you get to the code position where the signature is checked. You just search for the word signature and cross-references. Unfortunately, and luckily for RIM, the device checks that as well. So the signature is checked on the device as well, so it wouldn't boot your modified firmware. Quite a while ago, years ago, we did a talk on embedded systems that involved a Siemens mobile phone that died with a specific bug in reading JAT files, pretty much. We used those files and just checked them out with a Blackberry. Turns out one of them actually caused an exception in a browser that was not caught and left a dialog on the system open, which makes your browser freezing. Other things that there is still lots of stuff to do on a BlackBerry, especially on a device side. There's JTAG connectors. How many people of you have ever heard of JTAG? Can you raise a hand? Okay, very good. Good educated crowd. So JTAG is a hardware debugging thingy, in very short, which is quite useful because you can solder stuff to the device and do hardware debugging. Finding the JTAG connectors, Bluetooth, nobody played with Bluetooth on the BlackBerries yet. JVM bugs, I mentioned those, reversing the images, finding out what's going on, what are the checksums and stuff, or reading and writing memory. For the JTAG, at pH neutral, one of the German guys from CCC came up with a device called a JTAG finder. So he's connecting his JTAG finder to like every possible pin on the device and then has an ASIC that runs over all the connections and tries to figure out which is JTAG. So he found JTAG, and this is my specially modified BlackBerry that has a second cable, and then I had a nice person building this other special cable for me, because if I try to solder something, it just smells of integrated circuits. But now we actually do have JTAG on a BlackBerry now, and it's like you can actually Google for it. The guy who wrote the JTAG finder and built it has a documentation on all the JTAG stuff for the BlackBerry, so you can actually solder them on and get full debug access sub-CPU level. Mine doesn't work yet fully, but I assume that's just me. So for the protocols, I have to speed up a bit here. The protocols are almost boring once you figure them out. So it's called SRP, the Server Relay Protocol. That's the outer encapsulation, where you have an SRP header and then multiple payloads in chunks and a termination thing. Those are, I skipped those, they're here for reference. There are two types of chunks, which is integer and strings. There's not much you can do with that. There are a number of operational codes. We didn't play with them yet, so they're here for your reference and for your entertainment. If you don't have anything to do in your company and you have an enterprise server, this is the functionality the protocol provides. So there is still quite a lot of stuff that one can play with, like I would say config. Sounds interesting. This is how the session setup works. So the client actually goes to the server, like the enterprise server goes to RIM and sends a system ID, and then he gets a challenge, and they do crypto back and forth, and then they do init requests and result. The good thing is FTR implemented the whole thing as a Perl script. So we can be an enterprise server to RIM with a few lines of Perl now, which is quite useful for doing other stuff. Then you have, like in the SRP, you have the gateway message envelope, which is actually used for sending messages. And it includes the message routing information, pretty much like SMTP, where the email includes the routing information, which is sender and recipient and the message ID. Here's the format. Let's get that. And then you have application layer identification. It's going to tell you in clear text if it's like CMIME means it's an email message. CCAL is calendar updates. IT admin obviously is IT admin messages. And if you do some of the pin messages, like device-to-device pin messages, they're encrypted. And if you do like server-to-device pin messages, they don't have to be encrypted. Like if you write software on the server side, you have pin messages that are not encrypted. Also, when you use the Java API, I've seen several developers like repeatedly in forums tell everyone, do not just use the Java API and send a pin message because it's going to be unencrypted. And like the developers, some of them know and repeat it over and over again, but most of them don't. So many of the third-party applications actually don't communicate encrypted, although they think they do. The pin messages in clear are pretty useful because now that we have a Perl script talking to RIM, we can send messages. Again, format. And then application layer, payload in the whole thing looks like this. There's some crypto in there. I'm going to skip that. So about the crypto, in short, we don't know shit about crypto. So we just skipped that part altogether because it wouldn't make any sense to like look at the scrambled text and try to figure stuff out. There are other people doing crypto. This is a decoded dump. It's in the slides for reference. The thing is, based on that, you can do traffic analysis. So if you own someone's, some router in front of some company's internet connection, which depending on the vendor of the router might be fairly easy, then you can see messages going in and out. And if you see an email message coming in and afterwards a message coming out from a sender pin, which is the server, to a recipient pin that you don't know, and you have a content type that says CMIME, which is obviously an email, and you send another email in with the same recipient, and it comes another message out with the same recipient pin, then you know the pin, the device identification number of this email address. So you can do traffic analysis, and you can see who's actually receiving this stuff, even though it's encrypted. We had some fun with the SRP protocol, although it's so simple. There is something that's called the SRP ID and the SRP key. And the legitimate owner is disconnected, or more or less disconnected, when you connect with the same ID. So if you have two people connecting, it causes a routing problem at RIM's side because they cannot decide who's going to get the messages. So they essentially disconnect both. That means that like you get a new connection up. So, but the problem is if you do that like more than 5 or 6 times, it's going to lock you out because there's obviously a problem. The other problem is there is no procedure in place to inform the legitimate key owner that he's locked out. So I talked to a consultant setting up enterprise servers all the time, and he said they had this problem with 2 test systems, and they tried to figure out why they couldn't get a connection for a week till they called RIM and said, could you look up the database? And they're like, yes, you're locked out for a week. So that's fairly interesting. If you got someone's SRP authentication key, then you can make it pretty sure that for the next week there's going to be no Blackberries. Also, the SRP authentication keys is really interesting because they look like a CD key. They go like XXX-XXX stuff. So they're not considered a secret. I've seen presentations. You can actually Google for presentations that tell you how to set up an enterprise server. And I've seen presentations from security professionals, CISSP, who put screenshots on the presentation how to do the setup. Now the dialog is going to display that in clear text. It's not like styling it out or graying it out. It is displaying the SRP authentication key in full text. So the screenshots actually contain the most valuable secret that his company and RIM shared, and that authenticated his company to RIM and vice versa. So by just Googling, you can take over the BlackBerry communication of larger companies. And of course, there has been an implementation bug, which is an integer overflow. With the negative value of the string tag, it's going into an infinite loop. Quite useful, but I think it's fixed. Now the thing is that you have clear text pin messages, and now since we have a Perl script sending stuff, we can actually like iterate through all the device IDs and spam everyone, and you can actually spoof the sender. So we can send messages to pretty much every BlackBerry owner in the world and just, advertise that Finale Disco or something. I think they're in the process of making sure that you can at least turn unencrypted pin messages off, right? So you can turn them off to make sure that at least whoever communicates with you does have an enterprise server and not just a cheesy Perl script. The enterprise server. Let's look at the architecture a little bit more in detail. What we have here is the enterprise server box in the middle, here. And then you have something that's called the BlackBerry router, which is actually just an SRP talk and TCP relay. It's nothing fancy, it's just there, so this connection out to the internet to RIM does have a second hop and makes the security administrator who puts so much work into his DMZ a little bit more happy, but it doesn't really make any difference in terms of security. Then you have the management software here, and you have a connector to nodes, Exchange, or group-wise, and you have a required Microsoft SQL database. This is the account privileges. Earlier I mentioned that you should look at what processes need what privileges. And you see here, this is from the operation manual. I just make it a bit more readable. You see it's quite powerful. So the service account needs locally log on as a service, local administrator, read-only administration of the entire Exchange, and read and write administration access to the Exchange mail store. So that means if you own this device, you own the entire Exchange server. The manual says that you can put all those 3 accounts into one account. From the check marks, it's fairly obvious why, because they all need lots of privileges. The SQL database is interesting. It uses user authentication instead of integrated authentication in case of a Lotus Domino connector. I don't actually know why, but for Exchange, they support integrated authentication. For Domino, there is user authentication, which is well known to be not as secure as integrated. There are tables for individual messages. So if you have access to the database, then you can read everyone's email. There is a table with the SOP authentication key sitting there in clear text. There's a table with all the device keys, which is the previous one, the current one, the next one. And you can use the device keys to decrypt the traffic, which we did, and it worked. And the default account is SA and doesn't have a password. So if you have an enterprise server in your network at work, you should scan neighbor IP addresses, see if there's a SQL server running somewhere, connect without a password, and own the entire thing. If you find the authentication key in a database, which you will, because it has to be there, then here's an algorithm to translate it into something useful that you can then use in the protocols that we put the explanation on to connect to RIM and build your own cheesy Perl script to send spam to your boss. The good thing about updates in every piece of software is that when they fix something, you can bin diff it. So every update gives you a lot of information what they changed and what they fixed. The good thing with RIM is that, first of all, you get service packs and hot fixes, like with Microsoft. The release notes are extremely funny. It's just very entertaining reading. There are things in there like, I sent an invite to 2 people and someone else's birthday was deleted from the database. It's like, huh? Okay. But good. And what's also very, very interesting, RIM actually ships the debug information, the debug symbols, the PDB files with the updates. So if you have a vanilla enterprise server installation, you don't have PDB files, you don't have symbols, you don't have names for your functions. If you get an update, whatever file is touched will have the new PDB file with it. So suddenly, when you update your enterprise server, you get all the names resolved, all the classes resolved, everything else. Ida is going to be really, really happy. So talking about the code style, it is C++ by the book pattern implementation, fairly large classes, STL heavily used, pretty hard to reverse engineer, and it turns out it's surprisingly good code. STL helps a lot because if you have string classes, you don't go string copy everything back and forth. And the coding style seems to be, if in doubt, let's check. So the receiving function, for example, goes ahead and says, okay, I do a select on the socket and see if there is a byte to receive. Then I call a function. If there is a byte to receive, I call a function, which is going to do a select on a socket and see if there's a byte to receive. Then it calls a function, which is doing a select on a socket to see if there's a byte to receive, which then calls a function, which actually receives a byte. This is a coding style that is inherited on the entire system, and it is defensive coding. It is good. And one thing that I noticed was generally they are using signed integers. So if you're hunting bugs in enterprise server, go for signedness bugs. Interesting libraries. You want to see what libraries they use. We went for, obviously, parsing. We went for what stuff that's actually exposed to emails sent in and that operates on foreign data. So we went for the parsing, especially for the attachment parsing. For parsing Office documents, they just use the iStream classes. So if you have a vulnerability in parsing based on Office, then that might work. For HTML, they use MS-HTML4. There's MS-XML SDK installed. Apparently, according to Ian, it's for the sync server, but nobody knows why the entire SDK is really installed, so you get an SDK documentation on a desktop. And there's a parsing product from a company called Horizon that they bought quite a while ago that runs a central parsing engine and pretty much works like the Internet Explorer. So it takes the file extension and then looks at the first 5 or 6 bytes of the file and tries to figure out if it's the same thing. And then it kicks off some subparser. So in other words, if you're sending something and that's a PDF and you call it .doc and you manage to build a PDF that in the first 5 or 3 bytes looks like a doc file, which in this case is not possible, but in other combinations might, then you can smuggle a file in that's just a different type. And the subparser, then again, tries to figure out what it is on a different site. And so you could get around some protections and trigger some parsing bugs that you otherwise can't. Then there's zlib for decompression. The zip handling code, very interesting, is it looked from the coding style, it looked totally different than the entire other code. So I'm like, okay, why is this flat C code and everything else is C++? Turns out it's a copy and paste from the contrib directory of zlib. They just took the entire unzip.z and compiled it in. And of course, the zlib version wasn't really current. I think now they're running current? Current, okay. And for image parsing, there has been Graphics Magic. Graphics Magic is a spin-off from Image Magic. Now, Image Magic is not really known for very secure and good designed code. Graphics Magic turns out to be even worse. And the thing is, it was fully compiled with all debug code, with everything you can imagine, linked into the server. So I checked the website of Graphics Magic, and this is the file formats Graphics Magic supports. Now, this is quite a resource to find parsing bugs. So then checking the changelog tells you things like applied security patch from Christie. Looking at the security patch, turns out it stops doing mem copies all over the place with values from the file. And they constantly fix stack overflows while image parsing, which they don't even consider a security issue. So it even supports its own format string mechanism that it automatically applies to all image comments that you have, or image fields. Like most image formats support a copyright string where you can put in who made the image. If you put in like a 100% T somewhere in an image and send it to a BlackBerry user, the temporary file that's generated by the enterprise server for conversion will have a comment field that contains the file name of the temporary file, because that's what the library supports, and nobody actually cared about that when they compiled it into the enterprise server. And then, of course, you find bugs, because, well, if you have an open source library with all the debug information and all the version information, your binary auditing becomes a source code auditing, and you can easily grab for bugs and happily find integer overflows. In this case, heap overflow in a TIFF parser. So what programming should you never do? You should never take width of the image, height of the image, multiply them, and multiply that by 32 to figure out how much bytes you need as storage. Because if some asshole, like this one here, puts in like all f as width and like 10 as a height, the multiplication will overflow and you will allocate very little memory and put a lot of stuff in there. So that happened for the TIFF parser, that happened for the PNG parser. Interesting enough, the libpng people try to prevent people from being really stupid by putting a define in the code that defines a max width and a max height of 1,000,000, so that if you multiply both, you don't get over integers. The thing is that the image magic coder managed to multiply that by several other factors and still got an overflow. Of course, the zlib was pretty much not current, so there has been vulnerabilities in there. Interesting enough, the libpng that they linked with was absolutely current. So that, again, is very useful knowledge because you now know that different people are using different change management procedures when maintaining their code. One lib is current, one is not. Obviously, there is no process. Now, having vulnerability in the email attachment parser gives you the ability to, okay, so that's like, for everyone who doesn't know, that's the internationally accepted ASCII version of an asshole. So there are assholes on the internet, we all know that. So here is one, and it is sending an email to someone who has a BlackBerry with an image attachment. This image attachment turns out to explode right in the face of the attachment service, and you get code execution here. Now, it would be pretty silly to go ahead and have a shellcode try to connect back out to you, because if the firewall administrator is halfway worth his money, he's not going to allow this connection. So what you actually do is you own, of course, the entire system, and then you use the existing code in your enterprise server, call the existing functions and say to the SQL database, okay, retrieve, please, the SRP authentication key. And then you use other existing calls, other existing functions whose names were happily provided by the PDB files, and tell it, please send an email to measshole@hotmail containing the SRP key. So that is actually doable. Which means you have to separate the attachment service, because if you see it from a threat modeling point of view, attachment service is almost 100% attack surface. The only thing it does is parsing stuff that potential assholes are sending in. So the likelihood of something going wrong is pretty high. So what you have to do, and what's actually supported, is separate the attachment service on its own machine and put a firewall in between. So it's only talking to this box and not, to the internet. As of today, there is actually a white paper they just finished on the RIM website. It's probably really hard to find, but I guess it is there, that details how you do that. So if you're one of those poor people that have to care about the security of an enterprise server, it's highly recommended reading. Interesting enough, if you put an attachment service outside, then it needs a communication protocol to talk to the main server, which is unauthenticated XML over port 1999. And you can query stuff from the attachment service, but you can also set the number of processes, and someone forgot to put limits in there. So you can set the number of processes to 0, which of course makes it a very happy unemployed attachment service. Or you can try out how many processes are supported on Windows in concurrent running. So I got it up to 9,000 and then my machine froze. But you can set it to arbitrary values. So step 7, you do vendor communication. And that's really interesting and really important. Ian and I talked about a lot about this entire thing, because you need to tell people, and you need to tell the company that you attacked what you did, unless you have criminal motivations. Because both sides greatly profit from research people are doing, even if they're not paid for it. The well-planned, if your analysis is a well-planned thing, if you went ahead and followed more or less the steps I outlined in the beginning, then you can very clearly give an argument why you did that and what they have to focus on in the future to prevent this type of attack. I mean, we didn't attack BlackBerry because just because we hated them. We attacked BlackBerry because people really asked us for what do you think about the security of this stuff and where are the problems. Now the problems are known, so now RIM is in a position to have an outside opinion on how do people actually attack our stuff, where do we have to concentrate our efforts on, what they did. So they went ahead and reworked the entire attachment image parsing story, got rid of this hilarious piece of open source software called ImageMagick. RIM customers are actually like moving their stuff into the right position, separating the attachment servers, checking the database, because, well, in a default installation, you're happy if it works. Now they actually go ahead and see, oh, the database doesn't have an account or a password on the SA account. We need to set an account here. So people are securing this stuff. And then, of course, you can go ahead, print offensive t-shirts. I got you one, by the way. And meet with everyone involved and get drunk and like send greetings to everyone and stuff. Questions? As usual, nobody. Oh, question.
Why the separation of the attachment service under a different machine? Why not let the attachment service
Because a different machine is a lot less privileges than limited privileges. I mean, limited privileges is nice, but that assumes that your process separation is 100% working and there is no privilege escalation. And separate machine is a fairly cheap way of making sure that only a single port is open between the two machines. And that's a lot better. Otherwise, you just put your trust into the new Windows versions, which, I mean, with Vista, you would probably be successful in securing it, but it's just, the amount of trouble you can get into if you get owned does easily justify another 100 or 200 buck machine. The thing with the JTAG is the picture you've seen was taken just before I boarded the plane here. And when I tried debugging Access on this BlackBerry, it went like zzz, zzz, zzz. So I obviously have some hardware issues with my JTAG connection. So I can't answer your question yet. Okay, since everyone is leaving, I'm doing the same. Thank you.